Assalamualaikum. Nama saya adalah Ali Imran bin Syarudin. Saya dari kelas 2C dan nombor matrik saya adalah 2021 84 1008.
Assalamualaikum warahmatullahi wabarakatuh. My name is Putra Abdul Malik bin Zulkifli and my matrix ID is 2021496882.
Hello, Assalamualaikum warahmatullahi wabarakatuh. My name is Ibrahim bin Yahya. My matrix number is 2021-800-654 and I am from class 2C.
Assalamualaikum warahmatullahi wabarakatuh. My name is Putra Abdul Malik and today I would like to presenting about our topic which is related rates, which include the topic of application of differentiation. For the introduction of related rates and problems involving related rates take advantage of quantities that are related to each other. Related rates help us determine how fast or how slow a certain quantity is changing using the rate of change of the second quantity. The rate of change also is usually with respect to time. Without further ado, let's proceed to our first question.
Hey, good afternoon, everyone. My name is Ali Imran. Today, I'm going to show you how to solve a related rate question number 1. So let's start. So the question asking you, let V be the volume of a cylinder having height h and radius r, and assume that h and r are vary with time. So question A asking you, how are dv dt, dh over dt, and dr over dt related? And question B asking you, at a certain instance, the height is 6 in and increasing at 1 in second, while the radius is 10 in and decreasing at -1 in second. How fast is the volume changing at a time instant? Is the volume increasing or decreasing at an instant? So let's start with the solution number A. So number 8, so how to solve this question by we need to find the volume of a cylinder, which the formula was volume equal to pi r square h. So from dr over dt is equal to 2 pi r h and dh over dt pi r square. So let's combine both of them together. So you get dv over dt equal to 2 pi r h dr over dt plus pi r square dh over dt. So to solve question number B, let's go to question number B. So dh over dt equal to 1 cm per second, which means their height is 6. Meanwhile, the dr over dt equal to -1 cm per second, while the radius is 10. So very easy to solve this question. You just substitute the first question to question B. So right now we got the formula by 2 pi r h dr over dt plus pi r square dh over dt. So just substitute the information you got 1 cm, height 6, radius 10, and -1. Substitute 2 pi, substitute the the radius is 10, their height is 6, and their dr over dt is -1 plus pi over their radius power of 2, which is 10, and their dh over dt is 1. So you will get negative 120 pi plus 100 pi. So what we get is negative 20 pi. So it means negative means it's decreasing. So the question is decreasing, the answer. So that's it. So let's go to Baim bin Yahya question number 2. So let's go.
So for question number 2, a conical water tank has a radius of 3 cm at the top and 15 cm height as shown below. Water flows into the tank at a rate of 6 cm³ per second. And the question is, A, show that the volume of water given by V equal to pi h cube over 75. And B, how fast is the height changing at a rate when the height of the water is 5 centimeter. So let's look at the solution for this question. From the question, we can understand that the dv dt is the dv over dt is equal to 6 because it says that the water flows into the tank at a rate of 6 centimeter cube over 6 centimeter cube per second, and the height changing is 5. So for the question number 1, we need to prove that the volume is equal to pi over 75 h per sec h cube. So as we know that the formula for cone is 1 over 3 pi r square h. So to make it easier for us to solve the question, we eliminate the r so that we can get the r equal to h over 5. So that volume is equal to 1 over 3 pi r square over h, and we exchange the r into h over 5 square, h over 5, and so we can get the answer, which is pi over 75 h cube. Now let's proceed to solving the question B, which is how fast the height changing at an instant when the height of water is 5 centimeter. So from the question, we already know that the dv over dt is 6, and we would like to find the dh over dt when the height of the water is 5. So the formula is dv over dt equal to dv over dh multiplied by dh over dt. To get the dv over dh, we just simply need to differentiate the volume, which is pi over 75 h cube. After we differentiate the volume, it will be pi over 25 h square. Then we just simply put the volume into dv over dh, and we do a little exchange so that the formula will be dh over dt equal to 25 over pi h square multiplied by dv over dt. Now all we need to do is to substitute h equal to 5 and dv over dt equal to 6. So we will get the dh over dt equal to 25 over pi h square, which is h is 5, multiplied by dv over dt, which is 6. So we will get the answer for dh over dt equals to 6 over pi, which is equal to 1.91 centimeter per second. That's all for the solving of question 2.
Okay, now for the conclusion of this topic, which is related rates. In conclusion, when solving question about related rates, there is two options we can use to solve it, either using chain rule or implicit rule. And also draw a suitable diagram if possible, and identify the rate of change that are known and the rate of change is to be found. If necessary, use the geometry of the situation to eliminate one of the variable by substitution. We also must substitute the no of all given rate of change and the no quantities into the constructor equation. For the reference, we use two types of reference, which is the web reference and the video reference. And that's all from us. Thank you.